Hello, Assalamualaikum. My name is Afif Aiman. Metric number B1125101665. Today I will discuss question 1, A and B. Okay, for question 1A. The question is asked to construct the half-range Fourier cosine series expansion of the temperature function. Okay, first of all, we need to know the formula of half-range Fourier cosine series. That is Tx equal to A naught divided by 2 plus the summation from n equal to 1 to infinity an cos n pi x over L. And after that, we need to calculate A naught. For A naught, the formula is 1 over L. Integrate from L to negative L. This we get from the domain. The domain is from 0 to L, where L is 1. So we integrate from 0 to 1. And it's equal to 1 over 2 over 1. Integrate 0 to 1. And the fx function, 3 exponent 2x dx. And we integrate the function. And we get the answer is 3 exponent e power of 2 minus 1. This is the answer for A naught. And after that, we need to calculate an. The formula for an is 1 over L, integrate the domain, function fx cos n pi x divided by L, equal to 2 divided by 1, integrate 1, 0, 3 exponent 2x cos n pi x dx. And we will get 6, integrate 1, 0, exponent power of 2x cos n pi x dx. So to integrate this function, we need to use the standard integration formula. That is integration of power of ax cos bx dx is equal to exponent of power ax divided by a power of 2 plus b power of 2 a cos bx plus b sin bx. So from this formula, we will integrate it and we get the e power of 2x divided by 4 plus n power of 2 pi power of 2 and multiply by 2 cos n pi x plus n pi sin n pi x. And after that, we substitute the 1 in this and this, and we will get this. We'll get e exponent power of 2 multiplied by 2 negative 1 power n plus 0 and exponent power of 0 2 multiplied by 1 plus 0. And the answer is 12 multiplied by negative 1 power of n exponent power of 2 minus 1 divided by 4 plus n power of 2 pi power of 2. So this is the answer for an. And for the half-range cosine series expansion, we use this formula, half-range Fourier cosine series. We need to combine an and a naught in this formula. So Tx is equal to 3 multiplied by exponent power of 2 minus 1 divided by 2. This is in a naught plus summation of n equal to 1 to infinity. 12 multiplied by negative 1 power of n exponent power of 2 negative minus 1 divided by 4 plus n power of 2 pi power of 2 cos n pi x. This is an. So this is the final cosine expansion series. Okay, after that, for the question 1b, the question is asked by using the first three non-zero terms of the series, construct in A, approximate the temperature distribution. So for question 1b, we need to know the numerical approximation of exponent power of 2. That is 7.3891. And we need to find the A naught. The A naught divided by 2. So the A naught divided by 2 is 3 multiplied by e power of 2 minus 1 divided by 2. So we just to substitute this approximation to the A naught. So we will get the answer 9.5837. So after that, we will find A1 from the an function. So we'll just need to substitute the 7.3891 in this function. So we will get negative 7.2583. And also the same for A2. We just need to substitute the 7.3891 and we'll get the answer 1.7634. And the final answer is Tx equal to 9537, that is A naught, and negative minus 7.2583 cos pi x, that is A1, and plus 1.734 cos 2 pi x, that is A2. So this is the final answer for B.
Assalamualaikum. My name is Muhammad Al-Harith bin Muhammad Sharul. Matrix number B1125100186. Today I'm going to present and explain to you guys about question 1C. The Fourier cosine series is suitable for insulated boundary conditions because an insulated boundary means that no heat flows through the boundary. In heat transfer, the heat flux is proportional to the temperature gradient. Therefore, for an insulated boundary, the temperature gradient must be zero. Mathematically, this condition is written as del T over del X equals zero. This type of condition is known as Neumann boundary condition. The cosine function naturally satisfies this condition because the derivative of a cosine function is a sine function. D over dx cos n pi x equals negative n pi sine n pi x at the boundary where x equals 0, sine 0 equals 0. Therefore, d over dx cos n pi x equals 0, which means the heat flux is 0. As a result, the Fourier cosine series automatically satisfies insulated boundary conditions and is widely used in heat conduction problems involving insulated rods, walls, and other engineering systems. That is why the cosine series is suitable for this problem.
Assalamualaikum. My name is Muhammad Aiman Adi and my metric number is B112510158. So I'm going to explain for question 1D. So the question asks for half-range Fourier sine series expansion, which is the formula is this. Firstly, we need to find the Bn, which is the coefficient. So the formula for coefficient, which is Bn, is 2 over L integrate 0 to L dx sine n pi x over L dx. So from the questions, also we know that the L is equal to 1. So since L is equal to 1, we know that the interval, which is the limit, is 0 to 1. So just substitute the interval and also the tx, which is 3 exponent to x. So then next step is multiply the 3 with 2, then we get 6 integrate 0 to 1 exponent to x sine pi x dx. So to solve this integration, you can refer to the standard formula, which is integrate exponent ax sine dx dx. Then we'll get this from that standard formula. We just substitute, which is the a is 2 and b is n pi. So after we substitute, we get e exponent 2x over 4 plus n square pi square times 2 sine n pi x minus n pi cos n pi x. Then we need to apply the limit, which is 0 to 1. First, we apply the upper limit, which is x equal to 1, and we know that sine pi x is equal to 0, and also cos n pi is equal to negative 1 to the power of n. Substitute it, then for the upper limit, we get this answer. Next, for the lower limit, we know that exponent 0 is equal to 1, sine 0 is 0, cos 0 is equal to 1. So for the lower limit, we just substitute the value just now, and we'll get negative n pi over 4 plus n square pi square. Lastly, to find the Bn, just substitute the lower limit from the upper limit, which is Bn is equal to 6 times n negative n pi exponent square times negative 1 power of n over 4 plus n square pi square negative minus negative n pi over 4 plus n square pi square. Then just factor out the common terms, we'll get this. And lastly, since we get the final answer for the Bn, which is the coefficient, we can refer to the formula for half-range Fourier sine series expansion. So just substitute the value of Bn, then we'll get this final answer, which is Tx equals to summation n equals to 1, 6 n pi over 4 plus n square pi square times 1 minus exponent square times negative 1 to the power of n times sine n pi x. So that's the final answer for the half-range Fourier sine series expansion. Thank you.
2, 3, go. Now I will explain part E. Explain when the sine series is more appropriate in mechanical systems. The Fourier sine series is more appropriate when the boundary values are fixed at 0. This is because every sine function satisfies sine 0 equals 0. As a result, the Fourier sine series automatically satisfies boundary conditions where the displacement, temperature, or other physical quantity is 0 at the boundary. In mechanical engineering, sine series is commonly used in vibrating springs fixed at both ends, beams with fixed supports, heat transfer problems where the boundary temperature is maintained at 0. For example, in a vibrating spring attached firmly at both ends, the displacements at the ends must always remain 0. Since sine functions are 0 at the boundaries, they provide a natural mathematical model for this type of system. Therefore, the Fourier sine series is preferred when the physical problem involves fixed or zero-value boundary conditions. That concludes my explanation for part C and E. Thank you.
Good day everyone, my name is Edu Jarahana Jasajampi and my metric number is B1125100201. So I'm gonna answer question 2. A 30 cm long strip is fixed at both ends A and B. A point located 10 cm from point NA is pulled 3 cm perpendicular to the string and then released at rest when T equal to 0. So at equilibrium, the string is not pulled. And then when it is pulled at T equal to 0, from 10 cm away from A, it is pulled upward 3 cm. So the question asks formulate condition, identify the boundary condition and the initial condition. To find the initial condition, the boundary condition we can truly get from the answer itself. U0t is equal to 0 and U30t is equal to 0. And the initial displacement at t equal to 0, x is equal to 10 centimeter. So the equation, the x will be from 0 to 10 and then continue from 10 to 30. So from 0 to 10 we can get 3 over 10 x. From 10 to 30 we can get 9 over 2 minus 3x over 20. Hence the equation for initial condition is ux0 from 0 to 10 is 3x over 10, and from 10 to 30 we can get 9 over 2 minus 3x over 20. So question B, assume the wave equation is utt equal to 9ufx. Determine the general solution uxc using the method of separation of variable. So from this method we can get, we have given utt equal to 9ux. So we derive it to get this, and then we divide the part to get this. After that, we equalize for t term and x term equal to p to get each of its equation. Then we set the boundary condition u0t and u30t is equal to 0. x0 is equal to 0 and x30 is equal to 0. So this is the boundary condition. Now, for case 1, when p is equal to 0, when x is equal to 0, we using the x term to derive it to get this equation, a plus bx, then substitute to boundary condition. At x equal to 0, we get 0, and x30 we got 0 also. So we need to omit the solution. For case 2, p is greater than 0. Then let p equal to lambda square. Lambda square is greater than 0. Using the x term, we substitute into this equation, and then we get ae lambda x, ae to the power of lambda x, and be to the power of negative lambda x. We substitute to the boundary condition, we get x0 equal to 0, and x30 we got 0 also. So we need to omit the solution. Okay, go. Question 3, when k is less than 0. So we use the k as negative lambda square because it is less than 0. Substitute for x term, we get x square plus lambda square x equal to 0. And we can get it into x sine lambda x plus b cos lambda x. When substitute into the boundary condition, we can get x0 is equal to 0, dA is equal to 0. But for boundary condition 2, x equal to x30 is, we can get b sine 30 lambda equal to 0. We compare that sine 30 lambda is similarly to sine n pi. So we equalize 30 lambda with n pi, we get lambda equal to 9 pi over 30. And n is 1, 2, 3, 4 until it continues. So the x term is x and x bn sine n pi over 30x. For t term, we get t square minus 9pt equal to 0. Then substitute p equal to negative lambda square. We get t square plus 9 lambda square t equal to 0. And we can simplify it until m plus minus 3 lambda I. For the t term, we can get tt, the equation is tt c cos 3 lambda t plus t cos 3 lambda t. Then the finalized answer is tnt cn cos 1 over 10 n pi t plus dn cos 1 over 10 n pi t. Then we need to create a general solution. For uxt is xxt dt. uxt equal to bn sin n pi over 30x, cn cos 1 over 10 n pi t plus dn cos 1 over 10 10 n pi t. Then substitute bn into equal to sin n pi over 30x, an cos 1 over 10 n pi t, bn cos 1 over 10 n pi t. This is the meaning by that. So the initial condition of the general solution is this: an equal to 2 over 30 from 0 to 30 integrate from 0 to 30 fx sin n pi over 30x dx. Start.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilham Syafiq bin Syamsuri and my metric number is B112510168. So today I will explain to you about question 2C. So question 2C is estimate the displacement of the string at x equals to 15 cm. That is the midpoint, and at time or t equals to 5 seconds. So for question 2C, it wants us to use the first 3 non-zero terms of Fourier series for the estimation. So first, we assume that n equals to 1, 2, and 3. So for this equation, we will got it from the question 2b, and then we keluarkan that the question want us to substitute the x and t, and we got this. So we substitute the x and t in this equation, okay, like this. So after that, we simplify it to the new equation. Right. So for n equals to 1, So after that, we put up n equals to 1, 2, and 4. So we substitute the n value, and then we will got like this. And the n for the one n value is 0. So for the second n value, we also got it 0. And then for the third, we skip n equals to 3 because it is 0. So we took n equals to 4 for the third term, and we also got 0. After that, we add all the terms, and then we will got the answer, the final answer. Right, that's all from me. Thank you.